Number 13 then from the 2017 Advanced Higher. Here we go, 4 marks for a proof question. Use a proof by contrapositive, so you've got to do it that way. So you've got this statement which you're required to prove. It's not so straightforward to prove it directly because you'd have to express n squared as an even number, which you would then have to square root somehow. So what it's saying is use the contrapositive instead to prove this. Well, here's the original statement. It's made up of 2 parts. If, then. The contrapositive takes the statement and reads it in reverse with the negations of the 2 parts. So the contrapositive would say if, negation of this, n is even, no it's not, n is odd, okay. Then, negation of this, n squared is even, no it's not, okay, n squared is odd. There's the contrapositive, these 2 parts. If n is odd, then n squared is odd is the contrapositive statement to this one. And the point about the contrapositive is, the contrapositive is logically equivalent to the original statement. So proving the contrapositive proves the original statement. And it's easier to prove this one, because I can write n as an odd number quite easily. I'll just say this. Let n be 2 of something, 2k plus or minus 1, makes no difference. Where, importantly though, k has to be an integer. Well, now just work out what n squared is. What's the consequence of that? Well, I've got 2k minus 1 squared. So squaring that would be square the first, twice the product, square the last, which is positive. Now, is this an odd number? Well, it'll be an odd number if it's a multiple of 2 plus 1. And of course there's a multiple of 2 here. That's 2 times 2k squared, and that's 2 times 2k with a 1 left over. So I can state that that's an odd number. Or it would be an odd number as long as that's an integer. Wouldn't be an odd number if that was a fraction. So I'll better put it aside, since 2k squared minus 2k is an integer, because this calculation involving this integer didn't involve any divisions or square roots, for instance. Not sure if they'll be wanting you to should put that down, but I'm not sure if that'll be in the marks or not. And now that you've proved it, you'll have to justify what you did by making, now lots of statements here. So the contrapositive statement is true, which means since the contrapositive is equivalent to the original statement is true. Now I don't know how much they actually want you to write down there, but you'll have to make some sort of comment in the end that this is true, therefore the original one is true, and also the connection between the 2.